Hey everybody, Lars here. Tonight we are going to go over the second part of the Unit 2 slides, the part about loops. This is an important video. After this video, you are going to have the skill set to start actually solving some real problems. And you're going to see in this video, we're going to look over some real kind of problems. I know at first, when you first learn a programming language, it's like you learn about simple data, you can add numbers together, you can print things, blah, blah, blah. It gets kind of boring. Real fast, you realize, hey, I want to be able to make decisions. I want to be able to approach a large amount of data. I want to be able to do some different things. So we're going to be able to do that after we get loops under our belts, because loops are pretty powerful things. All right, there are basically 6 big things we have to go through. So I am going to get started. I am going to start from scratch and just get myself a new program over here. I will say File. I will say Save As. And I will go to our folder. Let's see. Python Data Science, Spring 2071. I did make a Unit 2. Look at that. And I'm just going to call this loops. So we got loops.py. When I'm done with this, as you know, I will be throwing this up on Sakai. So I will just say play with loops. Okay. All right. First thing we're going to do is the simplest thing we can do with a loop, but it is illustrative of something that I want to get across to you guys, because I know many of you have experience with other programming languages, and you are used to doing loops one way, and Python doesn't do it that way. All right, let's just print this and see what we get. If you are a crafty veteran and have watched review video 1, you know that that is a list, and then I'm just going to print said list right there, and I'm going to get a list: 2, 4, 6, 8, 10. Now, what if I wanted to do something to every single item in that list? Let's say I wanted to square it, and then I wanted to print out the square of that list. Well, the way we do that is to iterate over the list or loop over the list. So I'm going to do something for 2, then I'm going to do it for 4, then I'm going to do it for 6, and I'm going to keep looping until I get to the end of the list, and then I'm going to stop and continue on. Okay? If you have experience with other programming languages, say C or Java or something like that, you create something called a for loop. Okay? And it's no different in Python. We're going to do a for loop right now. But for loops in Python are different in that they're not complicated at all. All they do is iterate over lists. That's it. Okay? So if you've worked in another language and you're used to, well, first I have to declare the variable, then I have to set a condition, then I have to set my increment on A++ or B minus or blah, 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 blah. You have to set up that whole big control structure when you do for loops in C or Java or something like that. Not the case in Python. Python makes it easy. Python kind of takes the difficulty and throws it in the other direction. We'll see that when we do ranges. Because if you want to do a loop 20 times, you don't set up that big construct. What you do is you create a list from 1 to 20 and just iterate over it. Okay? So if you think about it, this is one of those things that after a while, after you've been a Python programmer for a little while, you're going to say to yourself, you know what? This makes a lot more sense than the other way I've been doing it my whole life. This is kind of easy. Just iterate over lists. You want to iterate over a different amount, then create a list of that different amount. Just iterate over the list. It keeps it simple. So anyway, I'm going to start by saying for. You see that idle colored it because it's a keyword, made it yellow. Then I'm going to say for I. Now, I is usually the variable we use when we iterate with lists. It likely hails from mathematics. Some people think it's I for iterate. But if we were going to use another one inside of it, which we will do a little bit later, we would use a J, and then we would use a K. I don't know. I think I may mention it in the slides and have a Wikipedia URL in there for you to go to. I don't know. It's a good question. But whenever we do something to iterate, we usually do I, J, and K. So I'm, God forbid I break the rules. I'm going to stick with I. And I'm going to say for, not for. For I in my list. I'm going to hit colon, and I'm going to hit enter. And you see how idle indented me for? Because idle, after that colon, expects me to create a code block. And then for every item in that list, what I have in my code block is going to be run. Now, I'm going to do the simplest thing we can do to start things off. I'm just going to print my I. And then I'm going to print the end at the end so you can see that it runs separately. So let's do that. And there you go. I print the list, then I print 2, 4, 6, 8, 10. So everybody gets individual treatment. And then I print the end at the end. So you can see print my list. My list is printed. For I in my list, grab the first item, 2. Print I, prints 2. All right, go back up to the top. That's why we call it a loop, because it pretty much goes in a loop fashion. Go to the top for I in my list. What's the next item? 4. Print I, prints 4. Just like that. And then it does 6, and then it does 8, and then it does 10 for my I, 10, print I, boom, and then it does 10. Then it goes to do it again, but the list is empty. There's no more there. It runs into what's called the EOL, the end of list. So then it says, okay, I'm just going to drop out of the loop, and then it prints the end. Okay? That is the simplest thing that we could possibly do. Now, because I want you to see that we're not just about printing numbers, I'm going to show you here. You can do something when you iterate. You don't just have to print the numbers. There, I squared them. So now we have our list, 2, 4, 6, 8, 10, and now we've listed out their squares, 4, 16, 36, 64, 10. Okay? We don't have to limit ourselves to one line either. If we wanted to, we could have a whole host of lines, and that whole block would be run for every item in the list. Just like it does there, see? For I in my list, grab the 2. Print 2 squared, 4. Print I, print 2 cubed, 8. Print a whole bunch of stars, go back and get another one. Next item in the list, 4. 4 squared, 16. 4 cubed, 64. Print some stars, go back and get the next one in the loop. So you can print an entire block, and as you can see, for every item in the list, I got the square, I got the cube, and then I got my little stars. Okay? So you can create code blocks. So you're not limited to just doing one line, and you can do things. You don't just have to, print the numbers out. You can do anything with the number, because whatever number you're using, it's represented by I in the code block. And then one by one, you're going to run these commands for everything in that list. Okay? What you're looking at now may not seem like the greatest shakes in the world. It's not the most complicated thing, but you're going to see that later we're going to be iterating over lists and files and things that can hold 1 million lines of data or thousands and thousands of data pieces. And you're going to see that computers are stupid. Computers only do what we tell them to do. But when we tell them to do something, and we tell them how to do something properly, they do it incredibly fast. And you're going to see later when we look at some of the bigger data sets that we're going to look at, that this is a powerful thing. And you're going to see that iteration moves incredibly quickly. Later on, actually, in this course, you're going to learn how to time your code. So we're going to be able to see how fast it is. All right, the last time I taped this video, I ran 54 minutes, so I cannot do that again. All right, what's the second thing I want to show you? The second thing I want to show you is something about a tool in Python called range. Let's say I wanted to get 10 numbers. I could say for I in range 10, print I. When I run that, invalid syntax. I won't have it. What I do here for I, what am I doing wrong? Print I for I in range 10. How about using the word in? Think that would help? All right. You could see that range function. It looks like a function. It's really not. I'm going to explain it in a minute. That function right there, I said give me 10 numbers. So it gave me 0 through 9. So it gave me the amount of numbers I wanted. And then I printed them down the line. So it seems that thing makes lists of numbers, which is kind of what it does, but there's a little rub in there. I asked for range 10, and it didn't get to 10, but that's because there's a little secret behind here. When I say range 10, I'm not really saying range 10. I'm saying range 0, 10, 1. Okay? I'm saying start at 0. 10 is the first thing I don't want. Make the increment 1. Okay? But the first one and the last one have defaults. So if you don't put them there, Python will default to start at 0, and Python will default to the increment as 1. Okay? So now when I ask for 10, I get 0 through 9. So I got 10 items. But because this is an interval, and if you remember what we discussed in the last video, when we talked about slicing, when we do intervals in Python, that's the first thing we don't want. Okay? So let's say I wanted a classic countdown. If I wanted a classic countdown, I would do that. And that would get me 1 to 10. Okay? Because I start at the 1, I get what I want to start with, and then the first thing I don't want is 11, and that'll get me to 10 by 1. Okay? Why stop there? Let's go 10, 0, negative 1. What do you think that's going to do? A little weird, right? Let's find out. All right, now we have a countdown. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Because I started at 10, 0 is the first thing I don't want. See, I got a 1. I gave it a negative 1. I said go backwards. Okay? That's the way we go backwards when we do ranges. All right? So when I'm printing all these out, I'm printing them out. But if I wanted to use it in a formula or, go down and decrease every time instead of increase, well, that's the way I would do it. I would do it with that negative 1. Okay? There's one last thing I do want to show you. I'm going to start with 1. I'm going to go to 101 because that's the first thing I don't want. And I'm going to increment by 5. I'm not limited to 1 or negative 1 or something that's single. Oh, what did I do? You know what? Let me do this. There we go. So now I get the multiples of, put that down there. So now I get the multiples of 5. 10, 5, 15, 20, 25, 30. All the way up and down the line. So I started at 0. 101's first thing I don't want. Increment by 5. And I go from 0 to 5 to 100. Okay? Word to the wise. By taking a look at this right here, you probably are thinking, oh, okay, range creates a list. And I iterate over that list. It's not really true. As you know, if you looked at that behind the scenes slide in our thing, range isn't a function. It doesn't create a list. What it is it's what's called a generator. It basically generates the next number in a sequence. So what we told it was start at 0 and increment by 5. So the next when it ran the next time, it gave me a 5. And then the next time, it just added 5 to it. And then it added 5 to it. And then it added 5 to it. It's generating numbers. It's a memory-saving technique. Because sometimes you don't want to iterate over a list because a list could be a million numbers long. If you know what a sequence is, sometimes you want to, use a generator. And we'll get to that later. I don't want that to confuse you. Right now, I just want you to know that range, and you can even see it. It's turned purple. So it's a function as far as idle can tell, but it's really something that we call a generator that's going to generate the next item in a sequence. But you don't have to worry about all that stuff. All you have to know is remember how it works. And I'm going to go set it back to its default settings, so you have that saved when you first bring the code up. Okay, those are pretty much the default, not the 10, but the 0 in the front and the 1 in the back, that's the default. All right, good. So you got a little bit of info about range there. Now, what I do at this point is solve a problem. Let's solve a problem because now we have simple loops in our belt. And what do we have from Unit 1? We've got some simple data, we've got if then, and what do we have from the first part of Unit 2? We've got lists and we've got strings. So the problem I usually solve at this point is, I'm going to say, of the first 300 natural numbers, how many of their squares are greater than 50,000? Okay, let's say somebody asked you that. They said the first 300 natural numbers, square them. How many of them are over 50 grand? Okay, how do we figure that out? Well, first thing I want to do is I want to see if I can list them. So for I in range What do I want to do? I want to start at 1. I want to go to 301 because it's the first thing I don't want. And I'm going to go up by 1. But I don't really need that because I can use the default. I can do that. And then I can say print I. All right, let's see what this does first. All right, it goes up to 300. That's a good sign. Let's see where it starts. Starts at 1. Okay, I'm in Fat City. All right, I'm doing pretty good here. So I listed the first 300, but I don't really want the first 300. I want their squares. All right, well, that shouldn't be so hard. Let's see. Instead of that, I will print their squares. Hey, hey, hey. Now 300 by 300 is 90,000. That looks correct. I come up here to the very beginning of the list, and what do I see? I see, oh, wait, hold on. Did I go too far? Yeah, I went too far. Oh, where's that 300? There we go. 1, 4, 9, 16, 25, 36. That looks like squares to me. So I am getting all the squares here. Okay, good. So now I created the first 300 squares. So that's pretty good. Problem is, I kind of want them in a format where I can tinker. So what I'm going to do is I'm going to create a list. Now, if you want to create a blank list, what you do is you give yourself a variable name. I'm going to call my list squares, and you make it equal to open bracket, close bracket, and that will give you a blank list, okay? And if you remember, I don't even think I'm going to print them. I'm going to take my list, squares, and I'm going to run that method I showed you last time called append. What am I going to append to my list? I'm going to append I. So every time I go through this loop and those numbers, I am going to, actually, I don't want I. What do I want? I want I squared. I'm going to append I squared, okay? So that's what that loop's going to do now. That loop is going to populate a list for me. And then when I jump out, I'm just going to print it. So squares. Now let's see what we got. Hey, hey, whoa, that's crazy. Hold on a minute. Let's see if we can make some sense out of this. Ooh, that was neat. Let me go a little bit further. That's weird. All right. You can see here the open bracket 1, 4, 9, blah, blah. This is our list. It populated our list, and the list goes all the way down and ends at 90,000. So we now have a list of all of the squares from 1 to 300. So we're in pretty good shape, but we don't care about all of them. We only care about how many are over 50,000. So what are we going to do? You get that pregnant little pause where I'm giving you time to figure it out in your head? Are you figuring it out? Think about it. We got a list with all of the squares in it. So what can we do? We can iterate over that list. So I'm going to say for I in squares. No more need for range. I got a list now. I know exactly what I want to go over. And then what do I want to do when I look at the square? When I look at the squares, what do I go? I'm going to look at 1. I'm going to look at 4. Then I'm going to look at 9. Then I'm going to look at 16, all the way up the line. But what am I looking for? I'm going to say if I, what? Greater than 50,000. If I is greater than 50,000, then I have a square. Print I. So now I should only print the ones that are greater than 50,000. Take a look. All right, things are looking good there, but that's not where I'm going to figure things out. I started here, 50, 176. Not too shabby. Look, I got my list right here, so let's go take a look. Where is it? I'm assuming that's it right there, but it's hey. But it got broken up. Let's do that. All right, 50, 50, 50. 50, 176 is the only one because that one's not. So that's the first one, and that's the first one we listed. All right. So we listed them. So what can we do now? Well, I guess we could eyeball the thing and count them. But there's got to be another way to do that, right? We're smart computer people. We've got to be able to find out another way to do that. I think there is. I think what we're going to do is we're going to do something like this. I'm going to grab a variable. I'm going to call it count. I'm going to set it equal to 0. I'll tell you why in a minute. And then I am going to create what's called a counter. And I'm going to put that in my loop. So I created a variable called count. I made it 0. Then when we jumped into this loop for the squares, every time there's a square greater than 50,000, I'm going to add 1 to the count variable. Okay. Now I had to declare it up here because right off the bat I used it. Remember when we evaluate expressions in Python, we're going to do it from right to left. So I couldn't just give it something that was not declared out of the blue. I had to declare it up here. So now it says count equals count plus 1. So every time I run through that, it's going to count. So what am I going to do? Because I'm a schmatty, I'm going to print it out. Let's see what we get. Hey, look at that, look at that, look at that. So now I'm printing out my list. Then I'm printing out the first value over 50,000. And then I put in a number next to it. So I now keep a count. And I can go all the way down. And I can see that there are 77. 77 of the squares of the first 300 numbers are greater than 50,000. So I've answered my question. And I've done it with programming. There's one more thing I'm going to do, because I want you to see it, is I'm going to accumulate them. So I'm going to create a variable called accum, and then I'm going to do something similar down here, but for the counter I added 1. For the accumulator, what do I want to add? There's that pause again for you to solve the problem yourself. I don't want to add 1. 1's going to be a counter. It's just going to count things. What I want to add is the item itself. So I want to add I. So I'm going to add the amount every time. And then as I go, I'll print it out. Okay? Let's go check that out. And there we go. So now when I get to the bottom of the list, I see that I have 77 of the 300 squares are greater than 50,000. And if I were to add them all together, I get 5,323,000 something. All right? So that's basically the small little program I do when we figure out how to do loops. And if you think about it, even from a data science standpoint, that's, it's not non-trivial. I mean, we're going to do much more complicated stuff, but imagine if you didn't have a computer sitting in front of you, how you would go about solving that problem for someone. Boss walks in the room, first 300 numbers, I need you to square them, and I need to know how many of those squares is greater than 50 grand. Now, you can figure out some heuristics. You could say, well, let me do 200 and see what that one does, and let me do this and let me do that. And you can figure it out that way. That would probably work. But even so, you'd have to do some equations. Most people, given this, would run out and throw it in an Excel spreadsheet, something along those lines. But with programming, you don't have to. You have it like this. And believe me, what we just did is overly complicated because you're learning. Once you get Python under your belt, you'll be able to do this in like 2 or 3 lines. Blah, 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 and do the whole thing. We would have done it up here in this section right here. I could after I do this, I could set up an if statement so that I would save in squares only the ones that were greater. And then I would, I'm not going to get overly complicated here, but if I wanted to, do I want to do this? All right. I don't want to get rid of that code because I want this to be the code that you get when you get the file. Squares, whatever. 1 to 300. So, if I squared is greater than 50,000, then append I squared. So when I get done, I'll have a list of just the squares that are over 50,000 and then print len, right? 77. Boom. What did that take? We knocked away half of it and did that. Now I'm going to say, what if I wanted to do the sum? I did the sum, and then I would do. And then we get that way, see? So there's easier ways. You're also going to learn through these things called list comprehensions that these 3 lines here, you can make all into 1 line. So there are going to be easier ways to do things. But for now, we're learning. And I'm not looking to freak you guys out. Let's see. I want to get rid of this. I want this. Wait a minute. I want that to populate that to do that to do that. And then I will rerun to make sure. And we are back in business. So you're going to get that now. All right. I also want to see how, I want to show you how with a loop we can do counters and we can do accumulators. Because sometimes you can't count on the external functions to help you, because sometimes you need to blast out in the middle of a list, and then you might need your own custom counter and accumulator, because then you're not going to be able to trust something else to do it for you. We're going to see that at the end of this video, all right? All right, we're already running long. Hold on. Let's go get an update. Oh, 25 minutes. That's not the end of the world. All right, I got 3 more things to show you really quick. First thing I'm going to do is I'm going to zotz this code. I want to make sure you have this when you are done. All right, I'm going to try and pick up some time with this next little demonstration. I am now going to show you nested loops. And a nested loop is just what it sounds like. For I in, I'm going to say range, some simple 3. I'm going to say print. I'm going to print the word outer. I'm going to print I next to it. Then what am I going to do? For j in range 5, I'm going to say print inner, comma, I, comma, j. All right, look at that. 4 lines of code. All right, but this is going to demonstrate a nested loop for us. Let's take a look at it. And as you can see right here, that's how a nested loop looks. I create a loop on the outside for I in range 3. So I is 1. I is actually 0 right now. Print outer and then I. So outer 0. So the inner loop now runs. For j in range 5, print inner ij. So you can see 0, 1, 0, 2, 0, 3, 0, 4. I run 5 times. Okay, 0, 1, 2, 3, 4. 0 to 4. Okay, then that loop is done. So it goes back up here. That is also done. So it goes back to the top loop and grabs the second number, which in this case is 1. So it prints it outer 1. Then it jumps into the inner loop again and does that 5 times. 1, 2, 3, 4, 5. See? And then you jump back here, you get the last number 2, and then you do it one more time. Okay? Now you're probably saying to yourself, why in God's name do we need to do that? Is that just a parlor trick? Is that supposed to be interesting? And the reason we do something like this is because you're going to find out later in the day, this is how we're going to access data that is stored in tables. Because if you think about it, we're going to have a list of lists whenever we have a matrix or a square of data. And the outer loop is going to be your row, and the inner loop is going to be your columns. So you're going to get row 1, 1, 2, 3, 4, 5, 6. And then row 2, 1, 2, 3, 4, 5, 6. Row 3, 1, 2, 3, 4, 5. That's the way we're going to access data like that. It's the way we access multidimensional data. Now, if you wanted to, you could add a k to that, and all of a sudden you would have dimensions of 3. So then all of a sudden, that to me, smells a lot like X, Y, and Z. So you can then start doing coordinates, okay? And then you could just, same thing. I'm not going to do it, but you could add another, line right there. You could add time, start doing physics applications. This is how in the future you're going to see how we access, different table data with nested loops, okay? A word to the wise, nested loop question may show up on the quiz. Enough said. All right, we're going on to the next one. 1, 2, 3. Why am I there? 1, 2, 3. All right, the next thing I want to do, I believe, is a little thing called an interactive loop. Well, actually, it's not an interactive loop. It is an indefinite loop. You're going to see why in a second. So far, we've been doing for loops. We've been getting ranges and running over that. But we always know how many times we're going to loop. If I have a list with 17 things in it, we're going to loop 17 times. If I do use range and I get from 0 to 21, we're going to loop 20 times, okay? We know how many times that loop is going around. But what if we have situations where we don't know if we're going to keep looping? What if we have a condition that's in a certain state and we want to keep looping as long as that condition reads what it reads, and then when the condition changes, bloop, we stop. You know, do we have the ability to do that? Can we code that logic in our programs? Well, it turns out we can. And the way we do that is with a different kind of loop structure. So far, we've been using for loops, but this time we're going to use one called a while. And while is what it sounds like. It's going to be like, while this thing I'm going to give you is true, keep looping. And if it's not true, well, then we're going to stop. So what I'm going to do is I'm going to take a variable. I'm going to call it char, C-H-A-R for character. And I'm going to make it equal to y. Okay? And then I'm going to say while char equals y, which it does right now, because it's true. I want to run this loop, so I'm going to print loop. And then I'm going to ask, I'm going to say char equals input. Do you want to continue? Question mark, a colon, and like that. Okay? So, char equals y. While char equals y does it, yes, it's true. Print loop, then char equals input. Do you want to continue? So if I give it a y, it goes back to the top. While char equals y, it does do it again, do it again, do it again, until I make char equal to something that is not y. And then we're going to jump out. And when we jump out, we're going to print the end. Okay? Invalid syntax. I won't have it. Oh, look at silly. Look at someone using the assignment when he should use the equivalency. Let that be a lesson to you, ladies and gentlemen. All right, loop. Hey, do you want to? I sure do. Of course I do. This is a wonderful program. Loop, 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 loop. Now, what happens when I give it an end? We jump out, and it says the end. Okay? Now, this isn't the most secure program in the world because I'm seeing if char is equal to y. Okay? So when I run this, I'm going to say, hey, y, hey, y, hey, y, hey, y, hey, y. But now say I give it a g. Well, the same thing's going to happen as n because I don't care if it's an n. I care that it's not a y. All right? So I could change my program to be not equal to y, while char not equal to y. Is that what I want to do? While char is not equal to n. Okay? So now if I give it an n, so is char equal to y? While char not equal to n. True. I jump in and I keep doing it. So now all of a sudden I've kind of taken my weird condition. You go y, 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 n. And you might say, oh, okay, it works now, but it really doesn't. All I did was take the mistake and throw it on the other end. Because now I can put whatever I want here. It doesn't matter about the y. Okay? But when I give it that n, it works. The point being, look over here at our output. Here I did it, what, 9 times? Here it was 6. Here it was 5. Here it was 7. They're all different. We never knew how many times we were going to go through because we never knew when, I was going to give it the end that it wanted. So it's an indefinite loop. You don't know how far it's going to go. Now, it just turns out that this is an indefinite loop using a while, but this is also something called an interactive loop because it's interactive. I'm changing the variable with an input statement. The user is changing the variable while the program is running, so that's also called an interactive loop. But the point I wanted to get across to you guys is that I want to show you an indefinite loop. It's going to run as long as that condition is true. But if the condition changes, well then, things can flip. Me being who I am, I do game programming. So you know how when you play a video game or you do something and then at the end it says, want to play again? Yes or no? That's all that is a big while loop. Trust me, because I've programmed them before. You put that entire game in a huge while loop and just says, while want to play equals y, go. And then when it gets to the end, all it does is ask, you want to play again? And if you say y, well, then it's still true. Blah, blah, blah. So you start over and you play the game again. That's all it is. Trust me, it's a while loop. The entire game is in a huge while loop. All of those games. Okay? So while loops come in handy, especially in game programming. If you have a certain condition and you want to keep doing something, and then all of a sudden something changes, you move something or put something else, and then all of a sudden, you can't fire or an enemy gets killed or something like that, then all of a sudden you jump out of the loop and you stop doing that particular behavior. All right? All right. We got one last thing to look at, and I am really doing bad on time, I bet. Let's find out. 35. We might be all right. 35 isn't so bad. 35 for all this, and you get one more thing? I sound like a bad commercial. All this and more. There's more kinds of loops. Interactive, definite, indefinite. We've got loops and loops and loops. One last kind of loop. I'm going to create a list. I'm going to call it the list. Not my list, the list. These are some of the least creative list names in the history of list names. 300, why not? It's been a theme so far. And then I will go and all right, I got a list. And that list contains those numbers right there. What if I want to add the contents of that list? Well, I'm a smart guy. And I just got the power of the accumulator with me, so I know how to accum. I'm also smart, so I'm going to set it equal to 0 up here. So 0 for I in the list accum equals accum. I'm a smarty, so I'm going to say print accum, and I should be in Fat City. 443. I'm assuming that's true. It's one way to find out. And that is to cheat. It's not really cheating, no. Sum accum? No. Sum the list. Should be the same, and they are. Okay? But, and this is the point I wanted to make before, sometimes we want to use accum because we're going to break things in the middle. All right. I got a list. And then I've got a for loop down here where I'm looping through that list. You'll notice both times I got 443, right? Because I always started at the beginning and went to the end. Started at the beginning and went to the end. I always go to the end. All right? Here's your question. What happens if I want to bash out of the loop in the middle of it? Is there a way for me to do that? Is there a way for me to go 2, 4, 6, 8, 10? Wait a minute. I don't want to do 300. And just get out of the loop. There is a way to do it. Of course there is. Why else would I be telling you? Why else would I be doing this if there wasn't a way to do it? What if I just said, no, there's no way to do it. Thank you. Good night. Have a good evening. And please enjoy the Super Bowl. No, there is a way to do it. But you got to do it with programming. And I'm going to show you how. Let's say I want to add all of the numbers in this particular list until I reach 300. So there's a certain number we're looking for. And in computer programming, we would call that number the sentinel. And that's why this is called a sentinel loop. Because basically we want to keep going, and watch for something until we get to that number that we want to stop at. And that number is called the sentinel. And that's why these are called sentinel loops. So basically, if I want to stop in the middle, what's going to happen? I go accum equals 0. Great. For I in the list. Okay, I'm going to loop through the list. What do I want to do now? I've gone up here. I've grabbed the first number. So I is equal to 2. What do I want to do if I'm in a sentinel loop? The first thing I want to do is make sure my number isn't the sentinel. So I'm going to say if I is not equal to 300, well, then what do I want to do? I want to treat it normally, right? Is 2 equal to 300? No, so add it to the accumulator. Is 4 equal to 300? No, so add it to the accumulator. So if I do this not equal to, then I know I'm in good shape. But here we go. Eventually, you're going to get to 300. And when you get to 300, you'll say, if I not equal to 300. Well, that's not true anymore because it is equal to 300. So what are we going to do? I know what I'm going to do is I'm going to have an else to handle that situation. But what do I want my else to do? I want my else to stop. I want my else to say, that's it, we're done, I'm out of here, I've had enough of this party, I'm going home, I'm getting out of here. So how do we do that? We do it with a Python command called break. You see how Idle made it orange because it's a keyword. And what break does is break will knock us out of whatever loop that we're in. If else, that's a decision structure. That's not a loop. I want to break out of that loop. So break will knock us completely out of the loop and bring us here to print a cum. If this were a nested loop, that break would only break the loop in which it resides. So if you're in a nested loop, it's only going to break the inner loop. You'll go back out to the outer loop. We can show that. But this is going to break us out of the for loop. So what should happen here is I'm going to say for I in the list 2, is that 300? No. Add it to the accumulator. Go back and get another number. 4. Is that 300? No. Add it to the accumulator. Keep going until I see 300. And when I see 300, I don't add that to the accumulator. Now, that's often a big problem. Wink, wink. I just want to get out. So if it is equal to 300, I jump to the else and I break out. And then I print the accum. And if my math skills are there, let's see, 6, 12, 20, 30, it should say 30. Woohoo! And it does. Okay? So that is the last kind of loop that we are going to look at. That's called a sentinel loop. That's where you look for a certain value. When you find that certain value, you get out of town. You get out of there. You use a break. Okay? Now, there's another way to do it, obviously. I could say if I is equal to 300 and then do the break in there, and then say else accum equals accum, blah, blah, blah. But I usually use the not. I want to check for it right away and do things normally and then have the break be my else condition. That's how I've always coded them. But it doesn't really matter. Either way it works. All right? All right. So this is going to be the first really good. Do I have anything down there? No. The first really hot grand finale for you guys. Let's see what we get. Hello, look at all this. Is nuts. All right, let's go back and review all of the stuff we did. Where do we start? Okay, we started out at the beginning of our code with the small list, and then we showed with the blocks that we could do different things with it. I squared it, I cubed it, I did all of that, and then I printed the end when I was done. Here I showed you range, and we ended up with just a 0 through 9, but you can also go backwards, and you can also increment by different things. Make sure to develop a good facility with range, because it'll be very helpful in the future to understand how intervals work and how all the range function stuff works. And also remember, it's a generator. Then we solved a little problem. We took the first 300 numbers, we squared them, and then we figured out how many were greater than 50 grand. So it sounds a little dopey, probably is a little dopey, but you know what? We use computer programming to actually solve a real problem for the first time. That's what loops give us. Loops and lists. Loops and lists are powerful. You can do a lot of neat little stuff. We can, set up criteria and separate things with our if-then. And then when we do that, we can put them in lists. And then when we get a list full of something, we can loop over it. I mean, we're starting to get some tools in our tool belt, I guess is what I'm saying. So we got our list, and then look at this. We got our 77. And then look at that. We got our inner and our outer loop and our nested loops. And that's how we go through things. Then we, why, yes, I like this. And then I give that an N, and everything works. And then there's my 30 for my sentinel loop. Okay? As always, I'm going to save this code for you. It's called loops.py, and I'm going to put it in your Sakai resources, so you are going to be good to go. Announcements. We're there. This is cool. This is the cool part. We have to get to the end of Unit 2 before we have enough tools in the tool belt to go out and start solving some real problems, which is why in this unit, the next thing I do is I introduce you to Project Euler, which is a website that has a whole bunch of number problems. And now that you have some tools under your belt, you know how to iterate, you know how to handle variables, you know how to handle if-then, you know how to handle lists, okay? Those are enough tools to start attacking some real problems and to start doing some things with our programming skills. So what I'm going to do in the next video, I'm not going to tell you too much about it now, is that I'm going to tell you the story about what we used to do when people came to the cave and said, I don't know Python, how do I learn Python? Okay, so we'll get to that. You're going to be able to solve some real problems now. Keep doing what you're doing. I'm assuming you're getting this beginning of the week of the 6th. So the Super Bowl is over. I'm actually taping this on Friday night. the weekend, the Friday leading into that weekend. So I don't know who won the Super Bowl. I'm going to root for Atlanta because I think the Patriots are evil, but I don't know who's going to win. I mean, can you bet against Brady and Belichick? My God, they're so good. But I'm going to root for Atlanta, and we will see what happens at the end of the day with that. You, on the other hand, just keep doing what you're doing. Everybody, my goodness, got their assignments in on time. The quizzes were all in on time. You guys are like little angels. So God bless you. Everything is great as far as that's concerned. I will be getting you the assignments in the next few days. I will be getting you an information sheet on the midterm project in the next few days. So I hope you will have all of your resources. I mean, if you're watching this, you probably do have all of your resources, because I want, the unit closes on the 16th of February. I want to make sure you have all the resources by, say, the 9th, a week before. So that means the slides, that means the book readings, that means the review videos, and that means the assignments. That Euler video isn't really a resource that you need to do well in the assignments or the quiz. So I just consider it like an extra, a little added extra, and not really part of the review process. So if I don't get you that until next weekend, that won't be too big a deal. All right. But I want to get it to you because people learn how to loop and people learn how to do stuff. And then you're like, oh, this is good. I want to give you something to practice on. So when I give people Project Euler, they go nuts. Project Euler is fun. And I'll tell you that story and I'll tell you how all that stuff goes. But I want you to be, my theory, if you were at the first class, learning how to program is a paint job. And the way I designed this course was that you're going to get 3 coats. The first coat is you're going to work with the slides and you're going to work with the book. And you're going to spend 3 or 4 days doing that, maybe doing some exercises, looking at some of the code in the slides and working with that kind of stuff. Then the second coat is the assignments. Halfway through the unit, you're going to get the assignments. So now you're going to say, oh, okay, I actually have a problem to solve now. How do I use the things that I learned in the book chapters and the slides and the review videos and use that to solve this particular problem that I have? So you're going to go back and you're going to review the materials and you're going to look at it through a new lens, because now you're the person who is, having to perform that task. So you're not the learner anymore. You're the practitioner. You're the person actually doing something and solving that problem. Then there is the finishing coat. Then there is the third coat of paint. And in the third coat of paint, you're studying for your quiz. You've got the quiz the next day, or you're looking up resources while you're on there. And that's from a third perspective, because now you're not the learner anymore. Now you're not even the practitioner anymore. Now you're reporting out like an expert. Now you're reporting out like someone who's learned and used these things already, because you're finding the answers and because you've done the assignments that this works like this and this works like that. So I'm bringing you through the process when I do these things. It's not going to work if you wait until the last weekend and say, oh, I'm just going to read that and do this and I'll do the assignments and read the book right next to it and da da da. It's a crappy way to learn. It's the wrong way to go about this, because I designed it so you get those 3 different stages for every unit. And if you do it that way and you regard the material for just, say, 20 minutes every day, you will learn it so much better than if you try to do it for 3 hours the day before. And it won't work in Unit 3. Unit 3 will bite you in the ass. All right? I know. If you've got programming experience, Unit 1 was a piece of cake. And Unit 2 isn't exactly breaking your back either. Okay? Unit 3 will rip your leg off. Trust me. All right? So get into the habit. When I say engage with the resources early on, do so. Read the slides, read the book, get all that out of the way. All right? Then when you get the assignments, you'll have seen everything and you go, oh, I know how to do that, and I can do that, and I can do that. Okay? The videos usually come in handy when it comes to doing the assignments and things like that. Especially Unit 2. Unit 2, when you see the assignments, you'll like it. The assignments are clever, and you'll find out why if you do them, all right? All right, then I'm getting out of here. You're probably getting this in the beginning of... I was about to say enjoy the weekend, but you're not getting it this weekend. Enjoy next weekend, all right? How's that? That'll work. All right, I'm getting out of here. Hopefully I get to the Euler video soon, and I tell you all those stories, and you will be good, all right? Keep doing what you're doing. Bye.